Today in class we talked about analyzing fairness in different situations. Please make sure you've completed page 7 and then correct it with this section. So which spinner do I think matches with each set of possible outcomes? Well, looking at spinner A, I'm expecting that the numbers should be pretty close together because I can see that 1/3 of the spinner is each color or each number. So I'm looking for numbers that are relatively close to each other. So for example, here I see on the first data set I get 5 1s, 12 2s, 3 3s. They don't seem very close together to me. 7 1s, 4 2s, 9 3s. Not super close, but closer. And then 4 1s, 11 2s, 5 3s. Well, that makes me think that this second data set is probably most likely with spinner A, because again, those are closer together and I would expect to get them about an equal amount of the time. What about spinner B? Well, spinner B, I noticed that I have a 25% chance of getting a 1. I have a 50% chance of getting a 2. I have a 25% chance of getting a 3. So thinking about this, I'm expecting 2s to be the most likely outcome. And so let's look at spinner C as well, because I see something similar there. On spinner C, I've got 6 possible outcomes, and I can see that 3 of them are 2s. So 3 out of 6, or 50%, are 2s. And then what about the others? Well, 1s are 2 out of the 6 pieces. And so I'm going to think about 2 out of 6, or 1/3, about 33% of that spinner is made up of 1s. Which leaves me with 1/6, or about 17%, being the 3s. So spinner B and C are closer together. I expect to get B most of the time for both of them, but I would expect to get 1 a little bit more when it comes to spinner C. So looking at this, I see 5 1s, 12 2s, 3 3s, and then for the third data set I see 4 1s, 11 2s, 5 3s. I got 1s a few, like one more time here, and that's not super significant because it could technically be either one in some ways. But if I'm going off of what I think is the most likely, I have a feeling that that first data set is probably going to go with spinner C because I got 1 more time. And that leaves me with the third data set matching with spinner B. Again, there are some different ways that you can perhaps argue this, because experimental probability, we can get all sorts of different things. However, we're thinking about what's most likely. So which spinner is a fair game for this situation? Well, looking at what's here, if I want player 1 to get a point for 1, 2 to get a point for 2, 3 to get a point for 3, I want all of those to be equally likely outcomes. And so that would give me spinner A as my way for equally likely outcomes to occur, right? Because I notice I have my chances of getting a 1, for example, are 1/3. My chances of getting a 2 are 1/3. And my chances of getting a 3 are 1/3. So everybody's equally likely to win. That makes it a fair game. So now what's a spinner that doesn't make it a fair game? How could we change it to make it fair? This one's going to have a variety of answers. Let's think about, for example, spinner B. When I look at spinner B, I notice that I'm likely to get a 1 25% of the time. I'm likely to get a 2 50% of the time. And I'm likely to get a 3 25% of the time. So thinking about this, perhaps I would award points so that player 1, if they get a 1, they would get 2 points. Player 2 would get 1 point. And player 3 would get 2 points, because I can see that the 25% parts are less likely, and by giving the person with the 2 fewer points, then I can kind of even out their chances of winning. That's just one possibility. You could also talk about it in some different ways. So Jake, Carl, and John are deciding what to do after school. Which strategy is a fair way to decide what to do? So we can see that there's 3 things that they want: video games, movie, and riding their bikes. So one of the strategies says to toss 3 coins. If they all match, they're going to play video games. If there's 2 heads, they'll see a movie. And if there's 2 tails, we'll ride our bikes. So it might be good to kind of think about what are all the outcomes if we toss 3 coins. So we've got heads, tails, heads, tails, heads, tails. We're going to toss one more time. So I'm hoping you remember that when we toss a coin 3 times, we have 2 times 2 times 2, or 8 outcomes. So we could get heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So thinking about this, if they all match, they're going to play video games. So matching, that would be these two here. That would be the video games. If there's 2 heads, so here I've got 2 heads, 1, 2, 3, have 2 heads, and 2 tails, I see 1, 2, 3. So are these equally likely outcomes? No, unfortunately they're not, right? There's 2 out of 8, 2/8 of a chance that we'll have a match, and there's 3 out of 8 chances that we will get 2 heads or 2 tails. So that doesn't seem very fair. Then if we roll a number cube, if we roll a 1 or a 2, we play video games. If we roll a 3 or 4, we go to the movies. Otherwise, we ride bikes. Well, the only other outcomes that are left are a 5 or a 6, and that's also 2 outcomes of the cube. So each one has a 2 out of 6 chance, right? So 1 or a 2 would be 2 out of the 6 outcomes. A 3 or a 4 would be 2 out of the 6 outcomes. So this seems like a pretty fair way to do it. Let's check the other ones though. Let's use this spinner. Looking at the spinner over here, we can see video games has about 50% compared to the others at 25. This doesn't look very fair. And then D said none of these is fair. But since we were able to find B as an option, then let's go with that. We'll see you tomorrow. We're going to play roller derby, which is a really fun game about probability. So come excited to roll some dice, some number cubes, and think about what outcomes are possible.